All right, so today we're going to look at solving polynomial and rational inequalities. Let me kind of scroll down for a second. So we're talking about solving these sorts of things that have quadratic expressions or polynomial expressions connected to the inequality symbol rather than just a linear expression of some kind. All right, so the steps to solve a polynomial inequality is that we're going to write the inequality so that the polynomial expression is on the left side and 0 is on the right side. And then we're going to determine the real zeros of the function. This is mostly done by factoring, by the way. So when we find zeros, we're really just looking for x-intercepts. Then step 3, we're going to use these zeros to divide the number. We're going to create a number line, and we're going to use these zeros to divide that number line into intervals. Then we're going to do what's called a test point process or a test number process. So we're going to select a number within each interval and determine whether the function is positive or negative based on that test value. And then lastly, number 5, we're going to use the number line and the corresponding sign chart, which is what we created in step 4, to write the solution in interval notation. Be sure to use any proper symbol for the endpoints, meaning open inequalities. We do parentheses, and any less than or equal to's or greater than or equal to, so the or equal to component will make brackets. In this first example, just kind of double check our steps here. We've got a polynomial expression on the left. We have 0 on the right. It's actually in factored form, so that's nice. It's kind of another step done for us. So we need to find these solutions for the factored part. So I'm going to take each factored expression and set it equal to 0 and solve. And I get -3 and 5. Okay, so then I'm going to create a number line. And in this number line, I'm going to label those two numbers. Okay, so what that represents, those are the two places where when I evaluate the expression for x, I get 0. So if I plug a -3 in, I get a 0, and if I plug a 5 in, I get 0. What I want to know is what's going on around -3 and 5. And so I'm going to pick some test numbers. I'm going to pick something smaller than -3 like -4, something between -3 and 5 like 0, and something bigger than 5 like 6. And now again, I just made up a number within that interval, and that test number is going to let me see whether I get a positive y value or a negative y value. And so I'm just going to evaluate the factored form. And that's one of the nice things about factored form is it's real quick to see positives and negatives. And I'll kind of write it out for this one, but then we'll kind of look and see what I mean by really easy to see. So if I simplify this, I get -4 plus 3, well, that's a negative number. And -4 minus 5, that's a negative number. And so a negative times a negative is a positive. So that part of my chart is positive. Then I'm going to do the same thing with 0. So 0 plus 3 and 0 minus 5. And 0 plus 3 is a positive number. 0 minus 5 is a negative. And a positive times a negative is negative, which tells me that that part of my chart is negative. And then same thing with the 6. So 6 plus 3 and 6 minus 5. So we get a positive times a positive, and that time we get a positive result. Okay. So then I'm going to go to my symbol, Symbol for this problem is greater than or equal to 0, so I'm looking for the positive values. So where in my number line do I see a positive? Well, I saw it before -3, and I saw it after 5. Okay, so I'm kind of shading in here on the number line what our solution set is. And in case you forget, why are these parentheses? If you go back to the original symbol, it was just greater than. It wasn't greater than or equal to. Okay. But that's my solution to this inequality, is the part that I've shaded in. So it's going to be from -infinity up till -3 union 5 up to infinity. Okay, now we're going to repeat this process. Now notice in this next example, it's the same factored form. So very quickly, I'm going to get my two numbers. And as a matter of fact, since it's the same numbers, exact same factored form, I'm going to take advantage of that sign chart that we just found. Kind of emphasize that you got to pay attention to what the differences between these statements are. And so here I want less thans or equal tos. Well, less than or equal tos would be negative, so I want in between -3 and 5, anything between it. So I'm going to put a bracket there. So bracket -3 all the way out to 5. Okay, again, and the sign chart part came from the previous example, so that kind of saved a little bit of space. But notice that symbol changes how our answer looks. Sort of related to it, but it does change how it looks. All right, let's look at this next one. This time I have to do some factoring. I can see easily that I can take a negative out, so let me do that. So negative x squared plus minus 4x plus 3 is less than or equal to 0. And then I want to do the factors on that. And so that would be x minus 3 and x minus 1 would be my factored form. And then I want to solve for where it equals 0. So I want x minus 3 equals 0 and x minus 1 equals 0. And that gives me 3 and 1. Okay, so on my number line, that's what I'm going to label is that 1 and that 3. Okay, so then from here, I want to pick some test numbers. So something smaller than 1, like 0, something between 1 and 3, like 2, and something after 3, like 4. And then I'm going to evaluate that in my factored form up there. So I'm going to look at this statement right here. Now, the nice part about factored form is, again, I can very quickly identify whether I get a positive or a negative. Okay, so let's say that I want to evaluate that at 0. So I'm going to come in here and I'm just going to put a 0 right above it. I have a negative for the first piece. 0 minus 3 is a negative, and 0 minus 1 is a negative. Well, what happens when you multiply three negatives together? You get a negative result. Okay. Then I'm going to come up. Well, let me kind of change the size of my eraser. Oh, sorry. Come back there. Okay. So I'm going to do the same thing with 2. So I'm going to put a 2 in for x, and I have that negative out front. Okay. So 2 minus 3 gives me a negative result. And then 2 minus 1 gives me a positive result. So what happens when I multiply a negative, and a positive? I get a positive number. And then I'm going to come in and do the same thing for 4. So 4 minus 3, 4 minus 1. All right, so we have a negative on the outside. 4 minus 3 is a positive number. 4 minus 1 is positive. And so what happens when I multiply a negative and two positives? I get a negative result. Then I want to look at my symbol. The symbol was less than or equal to 0. So I'm interested in the negative numbers. Okay, so before 1 and after 3. So that's the solution to my inequality, is negative infinity up till 1 with a bracket union 3 out to infinity. All right, so in this next example, notice the next 3 examples, they're all basically the same equation. The only difference is the direction that the inequality is facing. So that's just going to give us some practice. Once we've got our sign chart, that'll just give us some practice on reading what we want out of the sign chart, but we got to find our sign chart to begin with. So let's first off factor this. So this would be x minus 1 times x minus 1. Okay, which actually makes it x minus 1 squared. Okay, so then when I set that equal to 0 and solve, I get that x is 1. So in all actuality, I just have to put in a 1. So I want to test numbers before and after 1. And even though it's x minus 1 squared, I still get a solution of 1 once. I don't have to write 1 twice, even though there's 2 of them there. So we'll pick something smaller than 1 like 0, something bigger than 1 like 2, and then we'll come up and evaluate this form. Now, there's sort of a trick case here, and you'll kind of see what I'm talking about. So 0 minus 1 is a negative number, but I'm squaring it. So what do I always get? I always get a positive result. And when I come back up and put a 2 in, I get, let's see, 2 minus, I get a positive number that I square, I also get positive. So no matter where I am on the number line, I'm going to get a positive result, except for at 1, in which case at 1 I have a 0. Okay, well, what are we interested in? Well, I want positive numbers, and I got stuff before 1 and I got stuff after 1. So that's what I want to say. I want to say that it's before 1 and after 1, but not 1 itself. So negative infinity up to 1, union 1 out to infinity. Okay, now in the second illustration, we've got the same sign chart. Let me kind of translate this over here. This time I'm interested in negative numbers. So where would this thing give me a negative result? And nowhere. So in this case, I would have no solution. Okay, put the same sign chart up again. And in this case, the symbol says less than or equal to 0. So now I want to know, well, not only where the negatives live, but where do I even get 0? And in this case, I get 0 in one place, and that's that thing that I solved for. So I get it at x equals 1. So I do have a single solution in that case. When we deal with higher degree polynomials, we just have a longer number line that we're going to have to find test values on. So let's see, if we take each of our factored form here and set it equal to 0 and solve, we get x plus 1 equals 0. So x would be negative 1. We have x minus 2 squared, but that's really just x minus 2 that we have to worry about. So I get a 2 out of that, and I get x plus 3. That again, I don't have to worry about the squared piece. So I get negative 3. So on my number line, let's see, the smallest value here is negative 3, then a negative 1, then a 2. Okay, so I have one, I'm going to point them out. I got 1, 2, 3, 4. I got 4 places that I'm finding test values on. So I need a number. I'm going to come up here. I need a number smaller than negative 3, like negative 4. I need a number between negative 3 and negative 1, like negative 2. I need a number between negative 1 and 2, and 0 works. Anytime I can use a 0, that's a good one to take advantage of. And then I need something bigger than 2, like 3. Okay, and I am going to come over to my factored form, and we'll start with the negative 4. So I'm just going to rewrite this a little bit bigger so we can kind of see what's happening, and then I will do my substitutions. Okay. All right, so I want to start off with a -4, and all I want to know is whether it's positive or negative. Okay, so -4 plus 1 is a negative number. -4 minus 2 squared, well, even though inside it's negative, when I square it, I get a positive number. And the exact same argument for the last one, -4 plus 3. Whatever I get, I'm going to square and I get a positive. So I have a negative times a positive times a positive, which gives me a negative result. Then we're going to come in and we'll do the test point of -2. Okay, so -2 plus 1, I get negative. -2 minus 2, so square that, I get positive. And -2 plus 3 squared, I get a positive. So again, I get a negative result, and that's okay. And next up, we got 0. So I'll put a 0 in there. 0 plus 1 is positive, and I already know that even though I get 0 minus 2 is a negative number, I'm going to square that. So I get a positive, and then I get a positive. And what happens when you multiply 3 positives together? You get a positive result. And last but not least is the 3. So 3 plus 1 is a positive number. The two other terms are being squared, so they're always positive. And what do you get when you multiply 3 positives together? You get a positive result. Okay, so there's our sign chart. There's our number line. What do we care about in this? I'm looking for positive numbers. And I see that I get positive numbers when I am bigger than -1 up to 2 and bigger than 2. So that's what I want to write out. So -1 up till 2 union 2 up to infinity. And just a real quick sort of, I'll answer my own question. Why did 2 get a parentheses? How come I didn't put a bracket on there or something? What's so special about 2? And the answer is, if you recall, 2, if I use the number 2 in the original polynomial, I'm actually going to get a 0. So at 2, I get a y value of 0 instead of a positive number, and that's what we're interested in this particular inequality.